Hi everybody, this is Mr. Murphy, and today I'm going to be taking you through worksheet H, which is dealing with some math modeling. We're going to see some real world situations for the first time. You're going to see some techniques used here today, which are stuff that we learned back in first semester. So we'll see how much of that we remember, but obviously I'll kind of walk you through it as we do it. So example 1, if we look at it, jumping right into it. Find the particular equation of the cubic function containing these points. So we got 1, 3, 2, 4, 325, and 478. All right, so couple of key things. When they're telling us here, they're giving us some information. They're telling us that this is going to be modeled by a cubic function. That is extremely important for how we're going to solve this. All right, if we think about what the general equation of a cubic function is, we'd have p of x equals ax to the third plus bx squared plus cx plus d, right? So we basically have 4 unknowns here. We have 4 variables that we need to figure out what they are in our A, B, C, D. And how we do that, we're going to use these points. So essentially what we're going to do, 1, 3, obviously that's an xy value right there. We're going to take that xy and plug it into our general equation. So if we do that, if we start with, I'll kind of on the side here, if we start with 1, 3, and we plug that in, we would have y equals, so p of x, that's our y value, we'd have 3 equals, and then just anywhere that we see an x value, we're plugging in 1. So a times 1 to the third, we would just have 1a plus 1b plus 1c plus d. Right, if we continue on with this, if we take 2 comma 4, right, we'd have 4 equals. Now a little bit trickier, so we got 2 to the third, so this is going to be 8a. Right, now we got bx squared, so the 2 value is going to be squared here, so we're going to have 4b plus 2c plus d. If we do this with our remaining 2 points, without even writing the points, I think we get it at this point. We can say 25 equals 3 to the third, so we're going to have 27a plus 9b plus 3c plus d. And then our last point, the 4 comma 78, we're going to have 78 equals, so 4 to the third, we're going to have 64a plus 16b plus 4c plus d. All right, when I write it like this, hopefully this jogs our memory a little bit. We think back to first semester. I know in first semester we were only doing this primarily with our quadratics, but this should look familiar to you guys. We can set up, if we have a 4 variable system here that we need to figure out, we don't want to solve this out by hand. We want to use matrices. So the key thing with our matrices, right, I'm going to rewrite it how we would kind of have our matrix here. This is going to be a 4 by 5. Remember with this, we always want to put the y value at the end. So we got 1, 1, 1. The d value is always just a 1 for that. That's just constant. And then I'm going to bring my y to the end, so I have a 3 over there. I'm just going to rewrite these quickly. So 8, 4, 2, 1, and then bring the y value over. We have 27, 9, 3, 1, and 25. And then lastly, we have 64, 16, 4, 1, and we are bringing the y over for 78. All right, so that's what we essentially would be entering into our matrix. I believe that everybody has been using reduced row echelon form, which is we're referring to as our RF. Just to kind of go back over some of the steps to enter this into the calculator. I apologize, but I don't know how to pull up the calculator on the iPad, so I'm just going to kind of talk you through it a little bit. But essentially what you want to do to enter all of this in, if you hit your second matrix, so you'll find that just a couple buttons below the second button, you can go into matrix. Your first step is you have to go over to edit, right? So if you go over to edit matrix A, or whichever letter you choose, but probably matrix A, you want to input all of this in. So if we input all of this stuff, you set your size, you input everything. Now you need to quit out of that. Obviously, plugging in these numbers, you have to be really careful that you're plugging in all the numbers correctly, because the calculator is going to give you an answer either way. If you go back into the matrix, if you go in the middle column there, math, I think it's probably easier just to scroll up. I think it's letter B. That's where you're going to see this RF. So you want to select RF, and then once you do that, you go back into the matrix one last time, and you select your matrix A, and you hit enter with that. What you're seeing on the far right side, that far right side is our solution set. We should be getting hopefully 2, -2, -7, and 10. So I would suggest that everybody kind of pause the video at this point, try and plug all this stuff in, and make sure that we're getting those same values. What we just solved for, right? This is our A, this is our B, our C, and our D value. So if we put that all together at the end here, what we just got, this P of X equals A is 2, so we have 2x to the third minus, because of the negative, so minus 2x squared minus 7x plus 10. So matrices, obviously we spent some time with them first semester. They're going to come back and help us on these real world problems. So that particular one didn't have any real world implications. They just gave us some values and told us that it was a cubic function. Where these get a little bit more sophisticated are once we start adding some word problems to them and some real world stuff. So a lot of these will make sense over a particular domain, and then once you get outside of certain areas, they might not be as good of models, but usually they'll be pretty good for whatever domain that we're looking at. All right, let's take a look at number 2, our flagpole problem. So this is telling us in a stiff breeze, a flagpole bends in the shape of the graph of a quartic function. So again, we highlighted cubic before. This is saying quartic function, so 4th degree. That's important. That's telling us how we need to set this up, what we need to plug this all into. They're telling us a pole 10 meters long bends the following numbers of thousandths of a centimeter at distances x above the ground. So they're giving us a bunch of coordinates here. So we can take these coordinates, and I'm going to try and just jump right into putting them into our matrix. We'll see how we do. But what we're doing, because they told us it's quartic, what are we plugging everything into? It's going to be ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e. I'm kind of running out of room there, but that's just, we're just adding one more unknown here that we need to solve for. With 0, 0, it's going to be 0 all the way across. So for our ax to the 4th, bx to the 3rd, cx, dx. But now be careful here for our e value. That's going to be a 1 all the way through on these. And then obviously we have a 0 as our y on the end there. If we continue on with this, our x values for the next one are 1. So we're going to have 1s all the way across. And then that y we're going to put at the very end as our 561. For 2, 2096, right? So like I said, these are all just coordinates. So if it helps to look like that, you can do that. We got 2 to the 4th, so we're going to have 16 to the 3rd is 8. Obviously squared, we got 4, 2, 1, and then 2096. All right, for our 4th point here, 3 to the 4th, so we got 81, 27, 9, 3, 1, and we're bringing our y value over, so 4,401. Last point, 4 to the 4th is, we're going to have 256. We got 64, 16, 4, 1, and then we bring our y over 7296. So again, we want to take some time here. I'd pause the video for a second. We want to enter all of this into our calculators, use our RF function, and what I got out of that is 1, -40, 600, and then I got 2 zeros. So the zeros are fine. You should remember a little bit of what things look like if you're not getting a specific answer, correct answer as far as where the ones and the zeros are located. It should kind of be diagonally going downward in that sense, but you should remember that a little bit from first semester. What this is telling us as far as our general equation here for our particular equation, I guess I should say, we have 1x to the 4th, so x to the 4th minus 40x to the 3rd plus 600x squared, and then our d and e value in this particular case are both 0, so we can just leave it just like that. A lot of times with these word problems, you're going to have follow-up questions, right, to kind of answer some additional questions afterwards. So b of 5, b of 6, that's just saying f of 5, f of 6. It's saying just plug that into our x value, right? what's an easier way to do this than sit here and actually do 5 to the 4th minus 40 times 5 to the 3rd plus 600 times 5 squared? Obviously, there's not that many numbers. It's not too bad, but we're probably going to answer additional follow-up questions. So I would strongly suggest putting this whole thing into your calculator, into your y equals, and then in which case you can just go to your table, plug in a x value of 5, and you should be able to get this y value out of 10,625. Everybody hopefully remembers how to change your table so that it's on ask instead of auto. That'll be helpful on a lot of this stuff. And then you'd have for B of 6, it should just be a couple buttons that we're pressing. I got 14,256. All right. How far does the top of the pole bend? So this one, you need to kind of think about it with they're talking about the top of the pole. So we need to go back to the original problems that they gave us here. They said it was a 10-meter long pole. All right, so if it's 10 meters long, that's our x value, is the length of how long it is, and then the bend obviously is our y. So they're saying what's b of 10? We plug that in, so we're kind of already set for that, and we get 30,000 out of that. I think if we read the wording of this was in thousands, 30,000 thousands of centimeters. So this would be equivalent to, that should be roughly that should be 30 centimeters. All right. The last question here. Show that there are no real zeros other than y equals 0. So to do this, we can set this up. We're saying, all right, if we have y equals 0, equals x to the 4th minus 40x to the 3rd plus 600 x squared. What can we do with that? If we're trying to factor this, we can take out a GCF of x squared. So we'd have x squared minus 40x plus 600. So that x squared, obviously that's our 0. If we tried to continue on with this, if we went to factor this portion, or tried to factor this portion, before we even try and factor it, what's another method from first semester that would maybe help us here? If we check our discriminant on this, that should tell us. So the discriminant, if you recall, this is our b squared minus 4ac value, right? So if we plug that in, I got a negative 800 out of that, all right? The key thing just being the negative value. So the negative value means that this is not going to have any additional roots there. So our only root is at x equals 0, and we can see it's x squared, so that's going to be a double root, which we've learned obviously a lot more about in the last week or so here. That's really the gist of it for today, is understanding that for this math modeling, for our real world situations, if we're given a particular value of points, we're going to be able to use our matrices to determine the particular equation based on the numbers that they're giving us. What you need to pay attention to is obviously what the equation is following, whether it's a cubic function, quartic function. There's always going to be some information in there that tells you that. Then you can answer follow-up questions just by using a lot of the calculator skills that we have already acquired over the years, or over this year, I should say. Next class, you're going to look at some more sophisticated problems with some real-world modeling that will make it a little bit, hopefully more interesting for you guys, a little bit more calculator work, but for today's lesson, that concludes it. And just whatever your particular teachers are saying for homework, I think there'll probably be an exit slip, and then they might ask you to do some additional problems as well, because this really wasn't too long a video. So have a good day. Hopefully that all made sense, and talk to everybody soon.